Executive Director, Elizabeth Tennyson.
Thank you so much. And I hope you all enjoyed your lunch this afternoon, sponsored by Envoy Air. Thank you so much for that. I'd also like to welcome back our live stream audience this afternoon. So those of you joining us online, thanks for being here. Now it's time for a real taste of the future. And I'm really excited to introduce our final keynote speakers. We're featuring Uber Elevate today. Let's just take a quick glimpse into their vision of the near future. Closer than you think. It sounds good to me, right? Let's all fly over that traffic. So we've got a couple of great speakers with us today from Uber. Mark Moore, he worked for NASA for 32 years before joining Uber Elevate. And throughout his career, he has developed advanced aircraft with a focus on VTOL, vertical takeoff and landing aircraft. Over the past decade, he's pioneered the development of distributed I knew I was going to have trouble with this. Distributed electric propulsion systems. And those technologies are the fundamental enabler of new types of electric vehicle takeoff and landing aircraft. We also have with us Arianna Pilram Churchill. She's the chief of staff to Uber Elevate. In that role, it's her job to manage how the Elevate team is going to scale, grow, and diversify its workforce, something else we've been talking a lot about the last couple of days. She's also a student pilot, so we're looking forward to having her perspective on that as well. Please join me in welcoming Arianna and Mark.
Hello. I'm Arianna, so I'll start. Really excited to be here. Very happy to be invited and to be able to speak to this audience. What you are doing is amazing. And as she mentioned, I am a student pilot. My father is a pilot. My identical twin sister is a pilot. My husband is a commercial pilot. And that has nothing to do with how I ended up in this role, in this job, and on the stage today. Mm-hmm. I didn't even realize all of these connections until someone pointed out that everyone in my family is pilots, and that must be why I'm on the Uber Elevate team. But it really actually was not how I got here. So we'll get into that a little bit later, but it is a pretty exciting time right now to be involved in transportation, to be involved in technology, and frankly, to be working on something that did not exist when I was in high school. So I'm going to just walk us through a little bit about Uber. Mark's going to talk to us about some of the engineering and the great technology that we're building on our team, Uber Elevate. And then we'll talk a little bit about the diverse backgrounds on our team and how a lot of us got into this crazy world of flying cars. So this map right here represents New York City. It's in 2012. This is 1 year after Uber launched. And let's see if this will grow. what you're going to see here is a time lapse from when we launched in Manhattan and what happened to Uber as it grew in the area. We actually opened up to a lot of the outer boroughs. And today, Uber has made it possible for transportation to open up outside of Manhattan, all over. And this is something that we didn't expect. When Uber first launched, it was really for inner city travel. It was for short trips, black cars. But something happened, which was different people joined the picture. People thought beyond just what the original scope of what Uber could be and built something now that has global scale. If we look here, the same thing happened all over the United States. We launched in cities, but certainly you can see that Uber has grown all over beyond just major cities and is now a transportation option all over the United States. We have 15 billion trips over the last 10 years. 26 billion miles have been driven. We're in 700 cities, and I think that number has just gone up since I made these slides a couple weeks ago. And we're in 63 countries. So Uber now is becoming a verb, which is something that just didn't exist even when I joined the team about 5 years ago. So UberX was really just the tip of the iceberg. As I mentioned, starting with one product and one idea, press a button, get a ride, has actually turned into a whole lot of other things because the technology supported big ideas. So we introduced Uber Pool, then we went into Uber Eats, which is food delivery, and we have new mobilities, which covers scooters, bikes, and incorporating with public transit. And we also have Uber Freight, which is moving goods. As we've seen, there's been a lot of revolution in transportation and mobility as it pertains to cities. Every new step has let us move people faster and move things around differently. But if you think about it, travel times, especially in cities, has not changed much because cities are growing, more people are joining urban environments, and so we have more people, more things that need to move, and we have more on-demand services. So travel time has remained constant. Most commutes on average right now in the United States are actually still at 30 minutes. Our goal is to end dependence on personal cars and actually to open up mobility to make it something that is shareable and open to everyone and make cities and suburbs and other areas more accessible. We haven't seen a major transportation innovation actually in decades. As I mentioned, moving through cities has not changed a lot. Even with transportation changing, it's still the streets and the roads are almost the same as they were 50 years ago. It's really expensive to build roads, to build infrastructure in cities that already exist. Let me click through that one. And even when we have public transportation, the experience of public transportation isn't always the greatest. Even in cities that are super advanced, like in Tokyo, where they do have a lot of trains and mobility options, it's not the most comfortable way to get around. There's a lot of people using these services because we have a lot of people that, frankly, need to move around. So we don't think that cities need to look like that in the future. We don't think that cities need to keep building parking lots in places where we just store cars that are not being used all the time. As more people move into urban environments, we think that they can become green and open and actually more enjoyable places for everyone to live. We're working with thought leaders, policy, real estate, all of these different people that build cities in finding ways that we can unlock mobility and make it more accessible and allow people to move more free. So, how do we get here? Why are we on the stage today? Why are we talking to you? What is Uber Elevate? Mark is going to get into that, but something I wanted to point out is that transportation, as we've been talking about, is frankly just in the 2D space, in cities. You still move on roads. However, as we got more sophisticated with building, we started to cram more people in cities and move up. So we don't believe that we should keep transportation on the ground. We think that we should actually look at building transportation in the 3D space. So we want to move out of the 2D into the third dimension, and we do believe that transportation can be in the sky and moving people around. To make a route like this possible, which is from San Francisco to San Jose, which is a very popular destination for a lot of commuters, a lot of things need to be possible to fly those aircraft in the sky and move people around in an urban environment. And that is what Mark Moore is going to join us and talk about.
All right, thanks, Arianna. Perfect. Okay, so I've got to know who I'm talking with here. So how many of you are pilots? Oh my goodness. So that part of the crowd is going to think we're crazy. So let's get into it. and save some time for your questions. So I want to start by actually talking about, how I came into this and how this whole urban air mobility system started. And that is, it ties into a really important part of STEM. And that is, NASA laid the foundation for this over the past decade in developing new technologies. So this actually all started back in 2009 when 3 of us came up with this crazy little vehicle concept that is all electric and lets us design aircraft in completely new ways that can distribute the propulsion system and the control and the thrust across the aircraft in completely new degrees of freedom. So we started with this crazy concept and socialized it, and the established aerospace industry thought we were lunatics, right? Putting these heavy batteries on aircraft, well, what's more sensitive to weight than aircraft? Doesn't seem to make sense. But actually, we got funded for a couple little seedling efforts. So you can see here a wind tunnel test that we did at NASA Langley. And that looked so promising in terms of results that we were able to fund a little flight demonstrator, a UAV, which was the first distributed electric propulsion platform to actually be tested as a fixed-wing VTOL. And that was also successful in terms of demonstrating really incredible handling qualities and aerodynamic efficiency and propulsion-based control all the way through a vertical takeoff and landing to cruise to landing again. So that was successful enough that then we were able to scale it up to a meaningful size, and we couldn't afford a wind tunnel though. So wind tunnels are very expensive. They cost about $2 million just to get one test done of a large scale. So we had to take this wing that we had just enough money to build and put it on the back of the top of a tractor trailer rig and drive it across the desert of Mojave to collect data. And actually we had airbags, so we damped out the system. A lot of really cool seat-of-the-pants engineering that showcased just how much potential distributed electric propulsion had to integrate into aircraft in completely new ways to achieve all sorts of capabilities that we've been dreaming about since the Wright brothers, but didn't have the technology tools to pull it off. And I'm really excited. This is the X-57, which is the first human piloted X-plane that NASA has built in 25 years. So this is a program I'm especially proud of having started that. It's just about to fly. So you can kind of see the genesis where all this technology work was done by government researchers doing the wild and wacky, risky stuff that sometimes industry just can't afford to do. So now I'm going to talk about Elevate, because essentially the foundational technologies were proven. It's time for industry to get involved and to commercialize them into meaningful products. So what we did 3 years ago, as I joined, I left NASA and was the first person to be hired into Uber for Elevate. We essentially wrote a 100-page white paper that invited everyone to come together as a collaborative ecosystem of partners to create this new urban air mobility transportation solution. And here you can see the 4 core parts of this ecosystem, where you have the multimodal aerial ride sharing, that is the first and last mile, to work with Skyports, with heliports, to transport you across the city. The airspace control that has to be matched in very, very tightly with the network control. And then these brand new type of electric aircraft that are so different from helicopters, as well as the connected Skyports. So something much better than just a helipad on the ground. So I'm going to walk through these 4 different parts because it really gives you a feel for what we, as a collaborative ecosystem of partners, are doing together. It really starts with the vehicle. We cannot do this with just helicopters. And so as pilots and wannabe pilots, that when you design an aircraft, it's all about speed, range, and payload. And essentially we did studies that showed, hey, we really need these vehicles to be productive. They're still expensive, on the order of $2.5 million a piece. So being able to get 150 miles per hour out of them is really important. For payload, these are essentially, we found the sweet spot of aggregating people together, pooling people together, just like we do in big cities on the ground, to 4 passengers. We also have 1 pilot because everyone knows how important a pilot is. But we do look forward to the day when these aircraft can be autonomous. We will not replace the pilot until we have a burden of proof that the background autonomy and software is ready to be better and safer than the pilot. And we think that that demands, as we've talked to the FAA, that demands a statistical basis. So we're looking to be able to achieve on the order of 100 million flights with pilots in control of the vehicle before we would even think of having that autonomous software displace the pilot. And we're still going to need pilots in the background for emergencies and for evolving markets. So pilots will never go away. Don't worry about that. In terms of range, you're probably thinking batteries, not much energy there. Totally agree with you, but we don't need a lot of range. The juicy part of the market is in these large urban cities, and we don't need more than 60 miles. In fact, the average distance that we want to fly is 25 miles just to get across the city, to hop above that traffic and get from one part of the city to the next part of the city, so that you only need a very short distance drive from an Uber that would be waiting for you. So these vehicles really are not just designed by range paid payload and speed. Really, they are designed like no other small aircraft has been designed for safety. That's because these aircraft are going to be utilized about 2,000 hours a year to be economically productive. And so we need to be approaching that 10 to the minus 8th, 10 to the minus 9th system reliability that is on par with large commercial aviation transports. So they have a unique advantage, though, and that is, compared to helicopters, a helicopter has hundreds of single parts in them that are fault critical. And if one of those parts breaks, well, that helicopter is going to come down. With these aircraft, you can see they're designed with this distributed propulsion system. So they have no single part criticality. You can break any single part in that propulsion system or across that battery system or the control system, and it can still fly just fine and land safely. So that is the core difference that enables this new degree of safety, which is it's designed for full redundancy across propulsion and control. Another really important characteristic is being quiet, because these aircraft need to be able to take off and land in close proximity to people in these large cities. So they are being designed to be 15 decibels quieter than the quietest helicopters. Well, how quiet is that? The answer is quiet enough to map into the background noise levels for where we put the Skyports. And when they fly over at a 1,500-foot altitude, you cannot hear them on the ground, even if you're in a quiet residential neighborhood. That's how quiet and that's how focused we are on this objective to be good neighbors, because if you don't achieve that, there's no way cities are going to allow these aircraft to be in them. They're also green in that we are pushing for them to be all electric, not hybrids. Again, they're relatively short range, so the batteries are good enough to get what we want. And that leads to really good economics. EVs are great if you can put a lot of utilization on them in terms of having low direct operating cost, but they also give us zero emission vehicles that are, again, focused on community friendliness to not be emitting into the neighborhoods. So we, again, as part of this collaborative ecosystem, instead of being arrogant in Silicon Valley and saying, oh, well, we can just build these vehicles ourselves, what we did is we invited proficient aircraft manufacturers to work with us. And so we have 6 announced vehicle partners, several others that are not yet public, and all of them are developing concept and flight testing it to be ready to be put on our network. And they are not being paid. So all of these partners are coming in at their own cost. And each one of these, the flight demonstrator alone is a $50 to $100 million project. So they're really expensive. To certify one of these aircraft is between $500 million and $1 billion. And they're paying all of that out of their own partner. Each of us pay for our portion of this ecosystem as we develop it together. But if you look at each one of these companies, very reputable companies such as Bell, Boeing, some smaller companies you've never heard of like Pipistrel, every single one of the aircraft, if you'll notice, is completely different from the other. And that proves my point that we are in this wild, wild west era where we have a brand new propulsion technology that lets these aircraft be designed in weird and wonderful ways that could never be done before. And so we're in that kind of Wright Brothers era where people are building hundreds of crazy machines and trying to figure out which are the one or two really good approaches that will be the mainstream market. So another part of what we're doing at Uber is making sure that this passenger ride is really comfortable. And a lot of people have never even been up in small aircraft, and they're very nervous about it. So it's trying to get a good comfort level and feel to it and familiarity, and designing this cabin as a ride-sharing cabin. The economics don't work unless we pool passengers together. That's why Skyports are so important. They're not taking off and landing from your driveway. They're taking off from operationally controlled locations across the city where we can pool passengers together to get really good economics. In fact, this is what one representative Skyport is. You can see in the near term, what they'll be is adapted from elevated parking garages. So for relatively low cost, we can take the top deck of that and turn that into a Skyport and be able to get essentially the Skyport network initiated. It's really, really important that we have all of this controlled well in terms of the network management and airspace management. We call this the Elevate Cloud Services that we're developing at Uber. This is very much a software problem, and we're very much a software company, so it lends into our expertise, where we have on the order of 20,000 employees at Uber now. Most of them are software engineers, some of the best in the world. Essentially, there's several different parts to it, but I'll just equate to this story. And that is, our objective is to start with a handful of aircraft, but very quickly evolve to hundreds of aircraft in a single city. And eventually, over time, over the next 10 years or so, maybe 15, we expect some markets to get to 1,000 aircraft in one city. And I know you're thinking, wow, that's a lot of aircraft. But the cool thing about these aircraft is each one of them is 40 times more productive than an UberX on the ground, because we're filling them up and they're moving really fast. They're not stuck in traffic. So 1,000 aircraft is equivalent to 40,000 UberX on the ground, really productive vehicles. So if you think, wow, you're going to try to fly 1,000 aircraft over a city, this is where the pilots are going, oh, this is crazy. How many of you have been to AirVenture? All right, you know what I'm talking about. That is the busiest airfield in the world for about 2 days. And they sequence in with just a few rules of the road, not utilizing advanced precision navigation or anything else, but a simple tower saying, hey, Yellow Cub, you're next. And they essentially land 3 in a row on the runway. We can achieve much denser operations than we currently have, especially with the advanced systems that Garmin's and others are developing. We just need it all to be choreographed really well. And so that's what we're doing with NASA in a partnership where we're doing the simulations, just about to start flying experiments to validate the simulations. And we're doing this in partnerships with airports like DFW so that we can make sure we don't interfere with commercial traffic and we've got this all figured out. So once we figure it out in the first pilot cities of Dallas, Los Angeles, and Melbourne, Australia, then we'll be scaling this to the 50 top global cities across the world. And so we're really excited that this is essentially a global initiative. Just to give you a sense of a timeline as I finish up my effort, 2020, you are going to see some really exciting flight demonstrators as some of our partners who have been hidden behind the curtain are going to be public this next year. And you're going to see and hear just how amazing these aircraft are in 2020 through these demonstrations. All of these demonstrations and the testing and validation that we're doing will set up for us to start commercial service in 2023. And I know, again, you're thinking, wow, that's really soon. Well, we're only going to start with, that's when we get the first 5 aircraft. So very much we have this philosophy, which aerospace excels at, which is crawl before you walk, before you run, and making sure that you can do the operation safely before you attempt to go to scale. All of this essentially leads into optimizing the operations of these aircraft in the network into 2026, and that is our target for being able to achieve a price goal where it's a similar cost as taking an UberX on the ground, and that is by pooling 3 to 4 people into that cabin. They're each paying an UberX price, sharing the ride. It's equivalent in price to one person in that UberX by themselves. So we very much are designing this from the onset to be affordable and be a real transportation solution. In 2028, that's where we've proven all the assumptions, and you're going to see advanced automotive manufacturing and some other technologies show up, and that's when instead of these aircraft being made in the hundreds, will be made in the thousands, and we will scale to many, many other markets. So that's the timeline that we're shooting for. And I think the really important opportunity here is to accentuate how STEM education needs to be feeding this decade of effort to give us really capable people to be part of this new transportation system, which Arianna is going to go into further depth.
Thanks. So that timeline is wild. Whenever I mention anyone that we're doing this, they figure we're 10, 20, 30 years out, but it's not. Something I wanted to just talk about, I did a lot of research going into this because I really wanted to understand what a lot of you are up against. I'm just going to say this now. A bunch of people on my team are on the live stream, so I'm going to have to be fine with this. But I graduated high school 18 years ago. Makes me 36. Just did that math in my head. And when I was in high school, nothing that I'm doing today existed. Nothing. We had floppy disks, and there's probably people in this room that didn't have computers. I mean, there's a lot that can be said about where we are today and what existed when any of us were in high school. And the interesting thing is I interviewed a lot of people on my team to get their stories from high school as well, because we are all different ages and we come from very different backgrounds. And we always ask, people always ask me, how did you get that job? How did you do it? I'm like, frankly, it's just a series of really cool things that happened in my career and skills that were probably earned and grown in high school, because that's what gave me what I needed to be able to do what I do today, which is a lot of different things. So for all of you in the room that have students, I mean, most of them, when they are in the workforce and finally starting what you might call a mature career, nothing that they're going to be doing may exist today. So that was something that I wanted to point out. What I want to do is just go over a few of different people that are on our team that I interviewed to talk to them. I said I'm going to be speaking to a lot of teachers and administrators and people that work with high schoolers. What should we talk about? How do we explain what we do? How do we explain how any of us got here? So Rohit's super interesting. He's our operations planning strategic lead. He is tasked with figuring out our concept of operations and working with everyone on our team to figure out how exactly are we going to operate and do what we're doing. There's a lot to be thought of. It's how are pilots going to be certified with these new aircraft that don't exist yet? How are we going to operate things on the ground? How are we going to communicate to different people? That's what he's working on, but he didn't study that. He comes from India. He was really interested in sports in high school, and his parents forced him into engineering and science, but he really wanted to play sports. So sports is a big part of his background. And he was lucky enough to have teachers that allowed him to continue to play sports, and that's what made him such a great team player for all of us. He is the one that is the glue that keeps us together. He puts on a lot of fun social events for our team. And I love what he said about creativity, critical thinking, and empathy, because I work with him on a very technical level, but when he said that, I thought, oh, you're right. You do bring a lot of that to the table. And I think that's something that's very interesting for students today. They have access to technology in their pocket. They don't have to go to the library. If you say something in class, they can look it up right there on their phones. So they have so much information being given to them, but what can we do to support all of the other things that they may not find in their phone? How do you create an empathetic student who can look at a problem or take something that might exist, like the technology we have, and find new ways to use it? Let me see the next one. Christabel. Love Christabel. She's French, very French, and amazing. She is a senior advanced airspace services engineer. Due to her family circumstances, she grew up on airplanes from a very young age. She actually told me that the airport was her backyard. She loved airplanes. She's probably the one person on the team I can point to who knew she wanted this job, and she didn't even know what this job was, but she figured it out and made this job her job. And she wanted to follow in the footsteps of Neil Armstrong. She wanted to go where he went, so she did everything she could from France to make sure she got into Purdue. And then she had some amazing opportunities to be an intern and work at NASA. And through all of this, she actually is doing a lot of our airspace engineering. She's a partner on the airspace side. And what Mark was talking about is one of the major things we have to think about is how will these airplanes communicate and talk to each other and fly if we have so many at this altitude in an urban environment. And Christabel is one of those people that's solving that right now. It's really interesting. She pointed out that even though she knew exactly what she thought she wanted to do from a very young age, it was knowing that it was Neil Armstrong and always having a spark of curiosity so that every time she had an opportunity, she made sure that it was still fulfilling that curiosity that she had and her interest. So her advice is, if you've got students that are looking at different parts of aviation and aerospace and different science pieces, there might be some tie back to what we're building and what the future could look like that may not even be cultivated yet. Shabnam is from Iran. She's super interesting because she actually came from a background in economics and finance. She was a consultant, and the way that she got to the team is she saw Uber in her phone and thought she wanted to have more of an impact on the world, and she said, I'm going to do what it's going to take to get into that company. That's something interesting for your students, because right now they can start looking at companies that exist and think, I want to get there, maybe how do I connect the dots? Well, you all are teaching in aviation, I believe, everyone here. Here's an aviation platform. We're building it right now. So, your students may have heard of Uber, and now there's an opportunity to connect the dots because a company like ours is suddenly getting into aviation and supporting this entire new industry. So her story is different than Christabel. She went all over the place before she found what she wanted to do. She went back and learned how to code and has become an engineer on our team. So I think that's super interesting because she also agrees that you must stay curious. If you're not having the impact you want, if you're not doing what you're doing, if you don't know what major you want to have, that's okay. There's so many opportunities out there that you can do anything really as long as you stay curious. Luke is our head of flight operations. He's the one that's developing the plan for how we're going to get just enough of those pilots and working with hopefully all of you to figure out how we'll have enough pilots to support this future ecosystem. He was in special operations, and he has a really unique background because he wasn't in flight before, but he was able to learn how to fly on the job. And because he was a commander at various levels, he was actually able to be exposed, is what he says, to so many challenges and different problems that he had to learn, how to problem solve on the fly. And so he is one of our biggest problem solvers. He's thinking about all the things that sometimes we get really excited about and forget that, yes, we do need a lot of pilots. Yes, we do need the next group of aerospace engineers to be building this with us. And so he's involved in making sure all of those things are working together and that we never lose sight of where we are today and where we want to be in 5 years or 10 years. Jeez. Finally, we have Z. She's a data scientist. She comes from Shanghai. And what's interesting about her story is that from a young age, she just wanted to leave Shanghai. She knew there was a world out there. She wanted to explore. And today, she looks at the data that we have available as a company and as Uber and connects the dots about how we can use this data to help the rest of us figure out the future of what this thing could be. So she's extremely joyful in the office. She brings a lot of spirit for all of us. And her desire to explore the world and herself brought her out of Shanghai and basically through a series of really interesting situations into our office and working with us on the data team. She gives some amazing talks at universities, and she's very passionate about data, and that is what fuels a lot of what we're doing, is understanding what we don't know. We don't know what this future is going to look like. Nobody does. We're building the plane while we're flying it. I think that's what Eric says. He's my boss, and I love that because we all fly. And without the data of understanding what has happened before and what could happen, we wouldn't be able to push this as far as we have. So the last quote I'll leave with here is just solving a real problem cannot happen in a silo. You must understand cross-disciplinary applications of ideas. And that's something you can take to your students. Hopefully you're all taking pictures of a lot of the things we've shown. Our website has a lot of material there that you guys can use. And in a couple weeks, we're going to have a new media kit so you can download all of our videos and everything that you've seen today. Because none of us work in a silo. We have all of these different teams that are coming together. But if all of us didn't know how to merge or work together, or let me step out of what I'm doing and work on your problem, maybe I have some new ideas, we would not be where we are today. So let's see. I'm excited to introduce you to the product that we have on the ground right now, multimodal transportation. It's a grand problem. It's a challenge to figure out. I'm going to play this animation. How do you get a bunch of people in a city coming from all different points to arrive at a single location and take a flight? There's a lot of things you need to understand the weight and balance of what that flight will be. You need to understand where they're coming from and where they want to go. So right now in New York City, if you pull out your Uber app, you can move between JFK and Manhattan in 6 minutes. It's nothing that has been super possible or accessible to anyone that has a phone, but now you can do that. And because of a lot of the people that I just showed you, that's how this product became possible in New York right now. We've just launched it this year, but everyone I just showed you on screen is at their computers and trying to solve problems that we haven't even thought about when we're talking about moving people. So we're using this as a test because of the aircraft not being certified and existing in a way we can use. We can still look at bringing different people together in urban environments, getting them to a point, and then moving to another point. This is our team here with our CEO at our event, the Elevate Summit. A lot of them, I didn't even feature all these people, but it's just an example of the team and the camaraderie on our group. We love what we do. Most of us got here from very different backgrounds. We had no idea this could be a thing, but it's a very exciting time to be involved with it. So I think I'm going to leave us with a video, and then Mark and I will be happy to answer some questions. So thank you very much. It's been a pleasure to be here to talk to you about this topic. And hopefully you can bring it back to your classrooms because there's so much more that's going to be available in the future with aviation, aerospace, science, and technology. So thank you.
Who's first?
I'll take it. Wow. That just takes the breath out of me. I am so excited to see that. I think I saw something like that on Facebook, but now that I see it in person, and I think you might have answered the question I'm asking. In your marketing package, will that video be in that package?
It will. We'll have it in a couple weeks, probably, as I think we're just doing our website again. So yes.
Fantastic.
It'll be
Well,
available to you.
I want to put my bid in for next year. I'd like to bring you all to Birmingham and for our symposium, because I want to do this for the school kids, and I just believe we have to sell a dream early. And that's what I want to do. I would like to be able to use this marketing package to go throughout our school system and our district to inspire and to motivate the next generation. Thank you so much.
Oh,
Yeah,
thank you.
absolutely.
We have at least two of our team are from Alabama. Both Nikhil and Wyatt went to Vanderbilt, and they're two of the most productive, talented people around. So maybe we'll have to get one of them to come out and visit. Yes.
Hi, I just had a quick question about the electricity and just how you're providing that. I was reading a couple years ago about lithium ion, lithium polymer, and now lithium oxygen, and I was curious if you had any information about the lithium oxygen battery.
So I'll state that we are utilizing extrapolations of existing lithium polymer battery packs. They are, again, good, well proven and good enough for the range that we need. As you get into these lithium air or lithium oxygen systems, they're essentially air breathing. And they do offer a lot of potential in terms of more energy per weight of the battery, but they're still in the initial stages of proving them out. And really, they're not ready yet to be aerospace grade safe and proven. So we're excited about these advanced batteries. Air breathing batteries in particular have a couple challenges. They actually get heavier as you use them, about 10% heavier. So that's kind of weird for an aircraft to be growing in weight as it flies. So we don't like that attribute. But they do offer the potential to be much, much lighter. You're also going to see lithium metal batteries, probably more in that 28 time frame, which potentially could be about 50% to 100% better in terms of energy capacity of what we have now with the current generation of lithium polymer. I mean, this is an area where $2 to $4 billion a year are going into this battery research. It's an incredible opportunity for STEM students to grow into these chemical engineerings and many other jobs. And I can tell you, really one of the most important things is not just about, getting to the new cells. It's making sure that they're manufactured with incredible quality assurance so that billions of cells can be made and not one of them goes bad. And so it may not sound like the most exciting job, but quality assurance methods are just so critical to enabling the whole foundation of these batteries.
Good afternoon. First, I want to say the technology looks spectacular. However, I don't have a question about the technology. In addition to aviation, I also teach economics. And so you are telling me that these $2.5 million aircraft and the billions of dollars being spent to develop them and the tens of millions of dollars that are going to need to be spent for each one of these air hubs, that the cost is going to be similar to an Uber ride.
Yes,
Thank you. And so how much is the Uber ride?
So I got to tell you
$200?
a story, because I was leading the X-57 at NASA, and when Uber said, "Hey, why don't you join us?" and I'm like, I'm not joining until I see that the economics are going to make sense. So they actually spent 6 months putting together an initial analysis that they shared in the white paper, which was a little bit optimistic, but is essentially being well proven over the following 3 years since the white paper. So yes, absolutely. And the key ingredients, it really is about two things. It's about these electric aircraft that have really low operating costs because they have low energy prices and they have low maintenance cost. And that's well proven even with EVs on the ground compared to reciprocating engines. But the key with EVs is you've got to get a lot of utilization because they're really low direct operating costs, but they're high purchase costs. So we've got to get high utilization out of these aircraft to amortize the cost effectively, and then that DOC is really inviting. But again, you have to be flying with high load factors. We need to be getting 3 to 4 people in the aircraft, and that's the magic that lets you have a similar level of cost to one person in one car on the Uber in an UberX on the ground.
Yeah.
And just one more question. Are the pilots going to be independent contractors, or are they going to be or employed by Uber?
That's a good question.
So this is much more like commercial aviation, where the aircraft will be leased, just like United leases most of their aircraft. The operations are going to be Part 135. These are going to be salaried pilots, not contractors. These are going to be, essentially Part 135 operators that, have incredible training and operational requirements put on them. I mean, this is the key to a great safety record, is removing the uncertainty from the operations and having tight control over the pilot training, over the aircraft maintenance, over the operational environment where these aircraft operate. So think of it much more as commercial airliners that are really small.
Thank you.
How you doing? I'm Gary King from Armstrong High School in Richmond, Virginia. I'm kind of a follow-up on this question. What is the salaries going to look like? Because that's a big driving force for our kids, annually. Same thing with an hours issue. When you say commercial pilots, they only fly about 80 hours a month. Would that be different for Uber because they're going to be short hops? Can I explain that?
Do you want me to take it?
Okay, you can take that and then I'll follow up on
All right. So we're currently bookkeeping a burden salary of $110,000 per year for the pilots. We actually need about, I think it's 3.1 pilots per vehicle in order for them to be doing 8-hour shifts and be doing the training that's required. That's the basics for it, if you have follow-on info that you want.
I think the only thing I would say is that what's interesting about pilots in this job is that they'll be able to live and work in the same city. So you might have some pilots that love the journey, but if you wanted to be closer to your family, to your friends, or what you're studying, it's also an opportunity for pilots to live and work in the same city where they're operating. So that's an interesting piece of this that we've been exploring and looking at because it's a new opportunity.
Yep. Then the follow-on question is, where are we going to get these pilots from, right? Because there's a pilot shortage, we all know. And essentially, we're already working that with all of industry because we think instead of these being helicopter pilots that learn how to fly this unified control system, which is just a single stick, that it's going to be easier to train fixed-wing and general aviation pilots to fly these aircraft because it's much more like indicating a vector, a strategy, and not doing a cyclic and collective wrestling match with an unstable vehicle. So we're all working together on what's called SVO, Simplified Vehicle Operations, and getting that as a certificate that the FAA will be ready to accept as a basis for the pilot training for these pilots.
All right, thank you.
Well, you get this question, definitely, Arianna. You can.
give it that
That is an awesome question. Right, we're going to be flying at relatively low altitudes in the weather. One of our big questions as we're gathering that weather data is how many operational days will we get, especially since we'll be starting with visual flight rules, VFR operations. We won't be able to fly all the time. And that's why, as I looked across all of the companies in which to join, Uber has a huge advantage, and that is we don't need to fly all the time, right? We have a whole nother ground system where we won't strand somebody. I mean, it's not like if bad weather comes into a major airport, guess what? Everything gets shut down, and everybody is just built up because you still got flights 10 hours from now where they want to fly. And so bad weather for commercial aviation is horrendous because everything stops and then you've got a huge amount of volume to somehow get out of there. For us, we will predict weather as best as we can, and we're working with different weather forecasting mechanisms to do it much more precisely by adding weather instruments to every aircraft and do microclimate prediction. But you know, if we can't fly, we'll notify in advance and you know, still be able to do those trips, but twice as slow on the ground.
Yeah, and just to follow up on that, the reason why we've just been able to launch Uber Copter in New York City, we know that it's, you know, 1 or 2 aircraft a day that are flying pretty limited operations, but we can use that now in working with our really amazing software engineering team to figure out how do you mitigate those things. Like if suddenly the weather turns in New York and we do have people that are scheduled to fly in a helicopter, we can automatically dispatch cars that will move them in and out of the city and get them to where they need to do, hopefully relatively close to when they wanted to be there. But that is something that we're looking at now, and because we're Uber and we have this amazing back-end platform, which is really what we are, we're developing this huge platform, we can find different ways to deal with that per location. It's not one type of operation that we need to set, and that's the rule. It actually can change every day, every hour, and be super flexible. So that's something that we're really excited to be testing right now on the ground in New York because we have the ability to do that with helicopters. So.
But, and the biggest number one thing we'd love to change in terms of that weather restrictions is low ceilings, low visibility. And so it will be very exciting as we go from visual flight rules to autonomous flight rules, which are also a thing that we're doing across industry to prepare for, that if we can get these low-vis systems utilized and essentially the aircraft is taking over that navigational control, it's critical where you know everything is, but the actual visibility becomes less important for those autonomous operations. So that's by far the biggest weather problem, that there's clear technology path to addressing that.
Hi, my name's Dave. My question is, how do you envision the air traffic control challenges? I'm very familiar with the New York airspace, and you're not going to have 1,000 Uber Lyft people talking on a frequency. So how do you envision that looking with existing air traffic control challenges that are already in there? And will each Uber talk to itself autonomously like an ADS-B kind of situation? Or how will that look in 6 and 10 years?
Thank you for asking this question. This is an awesome question. And so the easy answer is no. We need voiceless, right? And that is one of the key things that we're working with collaboratively with NASA and the FAA to establish corridors where we can have voiceless control, self-separation of the vehicle, even in Class B airspace, because most of the cities where we want to fly, that's Class B. So essentially what we've done is hired some of the best and brightest from NASA again on the airspace side, who for the past 10 years have developed what's called UTM, Unmanned Traffic Management System. And so we're commercializing that just as Amazon and Google Wing are, essentially to be a system where we all communicate over a network. Every vehicle is known where it is. And as we fly in these corridors, that essentially we have specific equipage that the FAA has said, okay, you have been proven to be able to self-separate with this network control. We as controllers don't need to talk to you in order to authorize what you're doing. So it's very much all built on this background of UTM technologies that's getting to voiceless, corridor-based operations of self-separation. And I want to be clear, these corridors are not carved out airspace. They are free for anyone who has the equipage to fly in, but all of us who are operating in these corridors all are mandated to all be able to talk to each other on a validated, trustworthy system.
So these wouldn't just be Uber corridors. These would be FAA established corridors, and you would just borrow them, essentially.
We're not borrowing them. We're all coexisting in them. So if Airbus wants to spool up an UAM service, they're free to do it. They can operate in the same corridors. They just have to have the same network compatibility, so that we know every vehicle is essentially self-separating according to what the FAA has accepted.
Okay, thank you. And what kind of altitudes are you thinking, especially in a city like New York where you have 2,000-foot tall buildings?
So we won't be weaving in and around buildings. I can guarantee you that.
That's what I was wondering.
Up and over.
Yeah. So I mean, again, as Arianna said, we already fly Bell 430s from Manhattan to JFK. So a lot of that is actually over the waterway or cutting across the city. And so essentially we stay about 1,000 feet above ground level or building level.
Thank you.
And I just want to point out, too, that we have a lot of fun on our team. Everything that he's talking about is not happening at these little computers and everything. We are out in the field. We've got duct tape on drones. You know, a lot of what a lot of what you're teaching your classrooms, perhaps, we do as a team. So we come up with a hypothesis of something that we really want to figure out. We build these tiger teams. We pull from different groups on our team. And we solve those problems inch by inch. Like, we just carve out little things that we're trying to solve. And so, you know, I was super excited to be there the first time we flew a drone by controlling it with the Uber app. And it's remarkable how much we can get done because we have these small teams that just think about these problems, and everyone contributes with all of these different backgrounds on how we might solve them. So everything that he's saying is true, but we got there because we had to solve it first. We had to really think of these big problems and break them up and put together teams. Like, this team is solving seek and avoid technology, and this team is figuring out how far something can fly and it's still connected to the app on the ground. And we just had a team that did a partnership with Google, Amazon, and a bunch of other companies to figure out, let's all get together in a parking lot and see if our drones can see each other and talk to each other, which was a really cool thing. So perhaps we can share some photos with you, because I want your students to understand that we're having a lot of fun and that we're out on the ground doing these things. Oh, so I think we have time for one more question. Thanks.
Okay. I was wondering, and you mentioned helicopters, why you wouldn't just pilot this with helicopters currently, or can you modify helicopter technology to put this in place sooner? But I also was wondering about security, like how do we keep crazy people from hijacking one of these? So I'm sure you've got that all figured out.
I'll start with the helicopter question first, because that one I can answer. Helicopters are extremely loud. They're also very expensive to operate. And they're not built with a lot of redundancy in them either. So if you're going to be flying a lot of these at volume over a lot of people, you want to make sure that that aircraft is quiet, it respects the neighborhood and the place where it is, and that it's, you know, to speak about how we're going to scale these operations and keep the price where it's something that everyone can access, we have to be as efficient as possible, and we can't do that with the way that helicopters are maintained. So that's one reason. The other thing is they just don't scale. You can't have that many helicopters flying around each other with that much noise, because it would be super disruptive. So for all of those reasons, we are looking at helicopters. We're working with helicopters right now because they make sense to test our operations and our technology in areas where they already operate. We did not introduce a new helicopter route to test this. We were taking existing routes where helicopters are and making it more accessible for people on the ground to actually get in one and to try it out and to connect with an Uber to that ride. So I just wanted to make that clear. That's where we're working with helicopters and why these are not scalable for the future. Security?
I'll just add on, in terms of security and safety, we're going well above what Part 135 requires, because we want to be ahead of any requirement. Part 135 is usually, not a lot of operations. We know we want to get to a lot of operations, so we're essentially taking it on ourselves to take a lot of what's been developed in commercial aviation and bringing it down to Part 135, such as we have a safety management system that we've incorporated. We do screenings. Usually with Part 135, you don't have to do passenger screenings. We do that. Also, in the aircraft that we're developing, we're specifying a separation between the pilot and the passengers, so that passengers couldn't obstruct the pilot from being able to fly. While right now with Part 135, you can sit right next to the pilot, and so we're doing everything that we can to make sure that these aircraft are much more akin to commercial aviation operations than small aircraft Part 135 operations.
Okay, I think that I'm looking around for someone to give me a signal, but is that it? Oh, hey, there you are. Okay, thank you so much, everyone. Really appreciate
Thank you.
it.
Thank you so much. Thank you. That was great. Thank you so much, Mark. Big thanks to Mark and Arianna. You know, I take away from that a couple of things. The first one is more pilots. And the second one is, you know, we may not know what the future of the careers of these students that you're teaching today is going to look like, but we can say that having a background in aviation is probably not going to hurt. So I think there's a lot of opportunity there, really exciting stuff. It's kind of hard for me to believe that we're coming to the end, that this is our close. We've spent a couple of really great days together, and I hope you leave here with some inspiration and also some practical things you can take back to your classrooms. Maybe you made some connections here, people who can help you out with what you're doing, you can help them. You know, and there are a lot of goals to achieve, and I hope that you're a little bit closer after spending a couple of days here with us. I want to be sure that you all know that we're here for you all year round. We may only see you once a year or a couple of times at aviation events, but we're here for you, so contact us. Let us know how we can help you and how we can support your programs. Over the next couple of days, we're going to send you a survey. It actually might be more like a week, if I'm really honest, about this event. And I really do ask you to please take the time to fill it out. It's important. It helps us plan for next year. You don't be shy. Tell us what you liked, but also tell us what you didn't like. And we'll make a better event for you next year. So the next thing is going to be to tell you exactly where we are and when. Almost. I do want to say a very special thank you to United for letting us use this really amazing facility. I mean, what a place to be, right? Susan, would you join me on stage for just a minute, please? I hope you've all seen Susan White the last couple of days. She was a speaker for us, and she's been around the event. She's the reason we're here. She made this possible. She is unbelievably passionate about making new pilots and recruiting new pilots and bringing more people into aviation and the airlines and creating the future of our industry. So Susan, I want to say thank you for everything.
I appreciate that.
Do you want to say a couple words?
Thank you. Yeah, as I stated yesterday, thank you for everything that you do, because the sacrifices that you're making do not go unrecognized. And as I stated also, you're creating the future of our aviation and aerospace industry and the professionals that are to come. So thank you for what you're doing. You're not doing enough, and you're not recognized enough. So thank you very much.
Thank you so much, Susan. Thank you for being here. Okay, at long last, we're going to bring it to a close by announcing the location and the dates for 2020. Let's watch.
This is Orlando. This is where we believe in magic and fantasies and wishing upon stars and the power of the imagination. This is where we believe in dreams and seeing them come true. This is Orlando, known around the world as the home of happiness, and to those who live here happily, as home. This is more than just a place to stay a while. It's a place to stay on the cutting edge. Here, innovation comes in every form. Entertainment in every variety. And thriving businesses in every size. So if you think you know all there is to know about Orlando, prepare to be surprised. Because until you get to really know this place, this community, and and see all the reasons why it's so magical, rest assured, you don't know the half of it.
Yeah, so next year, November 9 and 10, next year. I see the cheering over here. I love that. We are going to be in Orlando. And you know, it is so much more than the theme parks, although, of course, we encourage you to visit those while you're there as well. It is a world center for simulation and aviation training. And you know, it's really just a few miles from Florida's Space Coast. So there's a lot to do. There's a lot to see. We're going to have a great time together. We're already planning some pretty unique and exciting aviation experiences. We're actually going to stay inside the Orlando International Airport, which is the 10th busiest in the world. So that's going to be exciting in itself. Keep your eyes open for announcements in the coming months. Thank you all so much for your attendance and your participation and your ideas, and we'll see you next year.